When installing multiple electrical circuits in a conduit, it's essential to consider derating factors to ensure the wires can safely carry the intended current. In this scenario, there are 3 new dedicated circuits for a kitchen: a 30 amp 240 volt circuit for the range, and 2 15 amp 120 volt circuits for the vent hood and microwave. Let's explore the factors influencing conduit size, the type of conduit, and appropriate wire selections. First, considering derating, the question is whether all 3 cables, specifically 16/3 nm cable and 212/2 nm cables, can be run inside the same 3/4 inch EMT conduit, given a maximum ambient temperature of 110 degrees Celsius. According to the NEC National Electrical Code, Table 310.15. E1. D. When you have more than 3 current-carrying conductors in a raceway or cable, the ampacity of the conductors must be derated. In this case, with 3 current-carrying conductors, the derating factor is 70%. This means that the maximum allowable current for each conductor is reduced to 70% of its original ampacity. For the 6/3 nm cable, which is rated for 30 amps, the derated ampacity is calculated as 30 amps multiplied by 0.7, which equals 21 amps. For the 212/2 nm cables, each rated for 15 amps, the derated ampacity is 15 amps multiplied by 0.7, which equals 10.5 amps. Because the derated ampacities are lower than the breaker sizes, and the conduit fill is within the allowable limits per the NEC, the 3/4 inch EMT conduit is sufficient. Secondly, concerning the type of conduit, both EMT, electrical metallic tubing, and PVC, polyvinyl chloride, conduit can be used. EMT conduit is often recommended for indoor use due to its ease of installation and flexibility. It is relatively easy to cut and bend, making it suitable for various installation scenarios. PVC conduit can also be used, but it is generally less flexible and can be more challenging to cut and bend compared to EMT. The choice often depends on the specific installation requirements and preferences. An important factor to consider is the type of wire used inside the conduit. NN cable, non-metallic sheath cable, is typically used for indoor wiring in dry locations. However, if PVC conduit is chosen, the NEC requires the use of THHN or THWN wires. THHN and THWN are both types of building wire commonly used inside conduits, particularly in locations where moisture may be present. The H in THHN stands for heat resistant. The first H indicates high heat resistance, the N stands for nylon jacket, and the W stands for wet location. THWN is similar, with the W indicating its suitability for wet locations. NM cable is generally easier to pull through conduit than individual THHN or THWN wires, which is why it is often preferred for indoor wiring when allowed by code. However, when using PVC conduit, individual THHN or THWN wires are required to comply with electrical codes. NM cable is typically used in residential buildings in dry locations. The outer jacket of NM cable is not designed to be exposed to moisture, so it is not suitable for use in wet locations or underground. THHN and THWN wires are commonly used in industrial and commercial settings where individual wires are pulled through conduit, or in any situation where the wiring may be exposed to moisture. Thirdly, regarding additional considerations for a proper and safe installation. Firstly, make sure to use a conduit body or junction box at each end of the conduit for proper termination and wire connection. Conduit bodies and junction boxes provide a secure and accessible location for making connections between the wires and the electrical devices or equipment they serve. Secondly, secure all conduits and cables properly to prevent movement and damage. Use appropriate straps, clamps, or supports to fasten the conduits and cables to the building structure. This helps prevent strain on the connections and protects the wiring from physical damage. Thirdly, follow all applicable electrical codes and safety guidelines when performing any electrical work. Electrical work can be dangerous, and it is essential to adhere to the NEC and any local electrical codes to ensure a safe and compliant installation. If the task is beyond your skill, hire a licensed electrician. In summary, The 3/4-inch EMT conduit is suitable for running the 3 cables after applying the necessary derating factors. While EMT is recommended for its ease of use, PVC conduit can also be used, but it requires THHN or THWN wires. Always prioritize safety and compliance with the electrical codes when performing any electrical work. When working with the electrical systems, understanding derating factors is crucial for ensuring safety and preventing overheating of conductors. The NEC provides guidelines and tables to determine the appropriate derating factors based on the number of current-carrying conductors in a raceway or cable, as well as the ambient temperature. According to NEC Table 310.15, the 1. Adjustment factors for ambient temperature are determined based on the insulation type of the conductors. For example, conductors with a temperature rating of 90 degrees Celsius, such as THHN and THWN, have different ampacity ratings at various ambient temperatures. At higher ambient temperatures, the ampacity of the conductors must be reduced to prevent overheating. Similarly, NEC Table 310.15, the 3 provides adjustment factors for the number of current-carrying conductors in a raceway or cable. When multiple conductors are bundled together, the heat generated by each conductor can raise the overall temperature of the bundle, requiring a reduction in the allowable ampacity of each conductor. These derating factors are essential for ensuring that the conductors operate within the safe temperature limits and do not pose a fire hazard. Additionally, it's important to consider the type of load connected to the circuit. Continuous loads, such as lighting and heating, are defined as loads that operate for 3 hours or more at a time. For continuous loads, the NEC requires that the overcurrent protection device, such as a circuit breaker, be rated at no more than 80% of the conductor's ampacity. This helps prevent the conductors from being overloaded and overheating during extended periods of operation. When selecting conductors for a specific application, it's important to consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the load is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction and reduce its efficiency. The NEC provides guidelines for calculating voltage drop and recommends limiting the voltage drop to no more than 5% for branch circuits and 3% for feeders. To minimize voltage drop, larger conductors can be used, or the length of the circuit can be reduced. When installing electrical wiring and conduit, it's important to follow proper installation practices to ensure a safe and reliable electrical system. Conduit provides physical protection for the conductors and helps prevent damage from moisture, chemicals, and other environmental factors. When selecting conduit, it's important to choose a type that is suitable for the application and environment. EMT conduit is commonly used for indoor wiring, while PVC conduit is often used for underground or corrosive environments. When pulling conductors through conduit, it's important to use a lubricant to reduce friction and prevent damage to the insulation. The NEC provides guidelines for the maximum number of conductors allowed in a conduit based on the conduit size and the size of the conductors. Overfilling a conduit can make it difficult to pull the conductors and can also increase the risk of damage to the insulation. When terminating conductors at electrical devices or equipment, it's important to use the proper connectors and terminals to ensure a secure and reliable connection. Loose or corroded connections can cause overheating and pose a fire hazard. The NEC provides guidelines for the proper methods of terminating conductors and requires that all connections be made in accordance with the manufacturer's instructions. Grounding is an essential safety feature of electrical systems that helps protect people from electric shock. Grounding provides a low impedance path for fault current to flow back to the source, causing the overcurrent protection device to trip and to energize the circuit. The NEC requires that all electrical systems be properly grounded and provides guidelines for the size and type of grounding conductors. Grounding electrodes, such as ground rods or metal water pipes, are used to connect the electrical system to the earth. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. Bonding helps prevent voltage differences between metal parts, which can cause electric shock. The NEC requires that all metal parts of an electrical system be properly bonded together, including conduit, enclosures, and equipment. Arc fault circuit interrupters (FSIs) are devices that detect arc faults in electrical circuits and energize the circuit to prevent a fire. Arc faults are dangerous conditions that can occur when damaged or deteriorated wiring creates a high-resistance connection, causing the wires to overheat and ignite nearby combustible materials. The NEC requires that FSIs be installed in all branch circuits that supply receptacles and dwelling units, except for certain exempted circuits. Ground fault circuit interrupters (GFCIs) are devices that detect ground faults in electrical circuits and de-energize the circuit to prevent electric shock. Ground faults occur when current leaks from a circuit to ground, such as when a person touches a live wire and provides a path for current to flow to earth. The NEC requires that GFCIs be installed in all wet locations, such as bathrooms, kitchens, and outdoor receptacles, as well as in other locations where there is a high risk of electric shock. Surge protective devices (SPDs) are devices that protect electrical equipment from voltage surges caused by lightning, utility switching, or other disturbances. Voltage surges can damage or destroy sensitive electronic equipment, such as computers, televisions, and appliances. SPD divert the surge current away from the protected equipment, preventing damage. The NEC recommends that SPD be installed in all electrical systems to protect against voltage surges. When working with electrical systems, it's important to use the proper tools and equipment to ensure safety and accuracy. Multimeters are used to measure voltage, current, and resistance in electrical circuits. Wire strippers are used to remove insulation from wires without damaging the conductors. Pliers are used to grip and manipulate wires and other electrical components. Screwdrivers are used to tighten and loosen screws in electrical devices and equipment. Conduit benders are used to bend conduit to the desired shape. Cable cutters are used to cut cables to the desired length. When using electrical tools and equipment, it's important to follow the manufacturer's instructions and to wear appropriate personal protective equipment, such as safety glasses and gloves. Lockout-tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. Lockout-tagout involves disconnecting the power supply to the equipment and placing a lock and tag on the disconnect switch to prevent it from being turned on. The tag provides information about who is working on the equipment and when it is expected to be completed. Lockout-tagout procedures are essential for protecting workers from electric shock and other hazards during electrical work. Electrical safety training is essential for anyone who works with electrical systems. Electrical safety training provides workers with the knowledge and skills to identify electrical hazards, use safe work practices, and respond to electrical emergencies. The NEC requires that all electrical workers receive appropriate safety training and that they be qualified to perform the tasks assigned to them. Regularly inspect electrical systems for signs of damage or wear. Check for frayed wiring, loose connections, and damaged components. Repair or replace any damaged components promptly to prevent electrical hazards. Keep electrical panels and equipment clear of obstructions. Ensure that there is adequate ventilation around electrical equipment to prevent overheating. Use caution when working near water or other conductive materials. Avoid touching electrical equipment with wet hands or while standing in water. Be aware of the location of overhead power lines and maintain a safe distance from them. Never attempt to work on energized electrical equipment unless you are qualified and authorized to do so. In the context of the question, the 6/3 nm cable consists of 3 current-carrying conductors, 2 hot wires and a neutral wire, and a ground wire. The 12/2 nm cable consists of 2 current-carrying conductors, a hot wire and a neutral wire, and a ground wire. Therefore, running one 6/3 nm cable and 2 12/2 nm cables in a single conduit results in a total of 5 current-carrying conductors. However, the question specifies that only the current-carrying conductors need to be derated, so the ground wires are not factored into the derating calculation. Since the conductors are insulated, the 70% derating factor applies, as determined by NEC Table 310.15. D1. D. The 6/3 nm cable with a 30 amp breaker requires a minimum ampacity of 30 amps. After derating to 70%, the allowable ampacity becomes 21 amps. The 12/2 nm cables with 15 amp breakers each require a minimum ampacity of 15 amps. After derating to 70%, the allowable ampacity becomes 10.5 amps. Therefore, the chosen conductors must have an ampacity of at least 30 amps and 15 amps, respectively, before derating. When choosing between EMT and PVC conduit, consider the application and environment. EMT is typically made of galvanized steel and is suitable for indoor use where physical protection is needed. PVC conduit is non-metallic and is resistant to corrosion, making it suitable for underground or wet locations. If using PVC conduit, the conductors must be rated for wet locations, such as THWN. NM cable is typically used for indoor wiring in dry locations. The conductors in NM cable are insulated and surrounded by a non-metallic sheath. THHN and THWN are individual conductors with a thermoplastic high-heat nylon insulation and are suitable for use in conduit, especially in wet locations. THHN is suitable for dry and damp locations, while THWN is suitable for wet locations. In summary, when installing multiple circuits in a conduit, it's essential to consider derating factors, choose the appropriate type of conduit and conductors, and follow all applicable electrical codes and safety guidelines.